Hi everyone, and welcome to this video on solving quadratics where the leading coefficient of x squared, or this quadratic, is not equal to 1. So far you've dealt with quadratics where that is typically equal to 1, so these are the hardest kinds of quadratics that you'll get at this level. In this example, we can see that our leading coefficient is 2, so we can't factorize and solve in the normal way. The way I do this is with a cross-multiply method, where I list the factors of 2 and list the factors of -3 vertically like this. It's quite simple in this case because the factors of a prime number are 1 in itself, so we just have 1 and 2, and we also have 1 and 3. Notice that there's actually a different way I could do this by listing the factors in a different order. So I can list 1 and 2 the same way, but then I could also list -3 as 3 and 1. Now at this stage, I'm not worried about negatives, so just ignore those. We'll deal with them a little bit later. So in this method, I cross-multiply, and I can see that I get 2 and 3, and if I cross-multiply here, I get 6 and 1. And the idea is to somehow combine these two numbers to make -1, or these two numbers to do the same. And only one of these combinations will work. And I can use negatives if I need to. And in this case, we'll see that actually it's this one and this one that are going to work. Because, of course, if I had -3 plus 2, I get -1. So this is my winning combination, whereas the one on the right will not work at all. So I can forget about that. Now that I've found my winning combination, I need to deal with negatives. So of course, I need to make one of these terms negative to actually solve this problem. So if I turn the 3 into a -3 and the 2 into a +2, then they will combine to make -1. That means I need to make this number here a minus and this number here a plus, which of course works because I'm trying to make -3 over here. So when I multiply +1 and -3, then I get -3. Now that I have that, all I need to do is put a couple of x's on there, get rid of this cross between them, and put some brackets around it. And I've factorized it. So let's write that out a bit more nicely as x plus 1 and 2x minus 3, which is still equal to 0 because I'm solving this problem. Just to quickly check that that works, let's expand them, which is always a good idea in an exam. So we have 2x squared minus 3x plus 2x minus 3. As we can see, these two middle terms here are exactly what we had up here and over here, and they combine to make -x. So we have the correct solution. When I try and find my solutions, once again, by writing it as factorized form, all I need to do is make sure that each bracket is equal to 0. So my first way of making that equal to 0 is just by having -1. My second way of making it equal to 0 is by having +3/2, or 1.5. Now let's verify that solution by looking at Desmos. So in Desmos here, I have graphed my original quadratic of 2x squared minus x minus 3. And as we can see, these are my two roots, or solutions, which are at -1 and +1.5, which match up with my two solutions that I found manually. So there you go. That's how you use the cross-multiply method to factorize and solve quadratics where the leading coefficient is not equal to 1. Thanks for watching.